Hello everyone. In this particular video, I would be focusing on the concept of stationary points. And what exactly are the stationary points? Stationary points are those points at which the curve becomes stationary. Literally, that's what it means. In other words, if I draw a tangent to the curve at those points, those tangents will be parallel to the x-axis. And what do we know from coordinate geometry? That if a line is parallel to x-axis, its gradient is 0. And what do we know from differentiation? Gradient of tangent to the curve at a particular point is also known as dy by dx, change in y with respect to x. Since there is no change in y, therefore gradient is 0, dy by dx is 0. That means in any situation, if I am asked to find the coordinates of stationary point, I should find the first derivative, that is dy by dx, and I should make it equal to 0. I hope everyone knows this for a fact, that we can write dy by dx, we can write y prime. If a certain function is given as fx, we can write f prime, that is the first derivative. Y double prime or f double prime, that is the second derivative. Now we know that the first derivative is used to find the coordinates of stationary point, the x coordinate of stationary point. How will you find the y coordinate? I'll leave it to your intellect to think about it. And of course, I'm very definite you will get it right. Now let's come back to the nature of the stationary points. Is it good? Is it bad? Is it ugly? That's the name of a movie. I'm not talking about that. I'm talking about when we talk about the nature of stationary point, we are talking about whether it's a minimum point or a maximum point. The rule is calculate the x coordinate of stationary point. It could be 1 point, it could be 2 points, it could be 3 points. Plug it in, the double derivative, the second derivative. If the second derivative is a positive value, we don't need the value, we need the overall sign. If the second derivative is positive, it's a minimum point. If the second derivative is negative, it's a maximum point. If the second derivative is 0, that means it's neither a maximum nor a minimum. Now somebody can ask this question, what do we mean when we say it's neither a max nor a min? Let's take help from a very simple graph. The graph of y equals to x cube. This is x-axis and y-axis. The graph is going like this and like this. Now, if I calculate, that I'll do in a short while, this is the turning point. Why it's a turning point? Because if I draw a tangent, the tangent would be parallel to x-axis. But is it a minimum point? No. Is it a maximum point? No. So therefore, it's neither a max nor a min. If I go back and if I draw the graph of y is equals to x square, so this point is a minimum point. Similarly, if I draw the graph of y is equals to minus x square, this is a turning point and this turning point is a maximum. So this is a minimum, this is a maximum. Why is this a minimum? Because the graph was going down, 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 and that's the lowest it could reach, and then it's rising up. It's just like life. There is a point that you reach, which is the lowest point, and then you rise up. It could unfortunately go the other way. In life or in this graph, you can reach a maximum point, and then this maximum will take you down. So minimum, maximum. This point is neither a maximum nor a minimum, because if it were to be a minimum, it should have risen up, which is not the case. If it's a maximum, the graph should have gone down, which is not the case. So it's neither a max nor a min. The proper terminology is point of inflection. We don't use this terminology in P1 or P3, but that's what the real terminology is. We are simply contented by the fact by stating it's neither a max nor a min. Now let's look at this first question. The question says, a curve has the equation such and such, write down expression for dy by dx which is y prime. Let me make the marker a little bit thinner. That's too big of a font. A font size of 4 looks perfectly nice on this thing. And let me choose a black, and this thing is done. Okay, so so dy by dx, this is y prime and this thing is y double prime. It says find the coordinates of the stationary point after finding the first and the second derivative and determine its nature. A straightforward question. Y is equals to x square plus 2x minus 1. Now this is not so straightforward for some people. I don't know, for some reason. You cannot apply the rule of differentiation unless and until you have everything in the proper format. That's what math is all about. It's not just about plugging in some numbers. Math is about logic. Math is about a methodology. That methodology needs to be followed. So y is equals to x square plus 2x minus 1. It's written in the index form. Now go ahead and differentiate. X square, derivative is 2x, and 2x minus 1, the derivative is, power comes down, x remains as it is, power reduces by 1. And then you can write it like this. You can rewrite it back in the fractional form. But since I need the second derivative, I'm not doing this thing in a haste. I'm first finding the second derivative. The procedure is the same one. I think I made a mistake. Let me correct my mistake. Have you realized what mistake have I made? The mistake that I made is this thing. Derivative of 2 is not 2. Derivative of 2 is 0. Let's move on. And I'll have to correct the mistake again. Stationary points y prime equals to 0. So therefore 2x minus 2 over x square equals to 0. And 2x is equals to 2 over x square. X cube is equals to 1. Therefore x is equals to 1. So this thing is done. When x is 1, you find the y coordinate, because coordinate means x and the y. That means whenever you have to deal with the coordinates of stationary point, you involve the original equation, you involve the first derivative, and you definitely involve the second derivative. The first derivative is what we get started with. We make y prime equal to 0, we find the stationary point or points. We need to find the y coordinate, we use the original equation. We need to find the nature, we use the second derivative. Now let me correct myself. This thing is, the 2 has to be removed. When x is equals to 1, therefore y double prime is 4 over 1 cube, which comes out to be positive. Therefore this is a graph of a minimum. Therefore, this particular point, 1, 3, it is in fact a minimum point. So that thing is correct. Now that was the first question. Let's move to the second one. The variables x, y, and z can only take positive values. That means if you get hold of any negative value, right away reject them. So reject any negative value. Now it says x, y, z can take positive values such and such. There is an equation which relates x, y, and z. There is an equation which relates only x and y. Show that. Z is equals to 3x plus 1200 over x. Now in this particular video, we are simply focusing on questions in which there is no involvement of application related to 2D figures, perimeter, area, 3D figures, surface area, volume, nothing to do with that. So we are focusing on the stationary points as it is, application of stationary points with respect to mensuration, with respect to similarity and what you call graphs and trigonometry and some other things that will come later on. So therefore, how would you prove? This is z in terms of x. Which variable is missing? Y. That means from the second equation, make y the subject. So y is 600 over x. Z is 3x plus 2y. That's 2 times 600 over x. That comes out to be 3x plus 1200 over x. Pretty straightforward. Stationary value, write in the proper format. dz by dx is this thing. Now, how did I write the answer so quickly in this scenario? Because I remember something in the box. What's in the box? Y is 1 over x, y prime is minus 1 over x squared. So this is a simple concept. You can just take it for granted. 1200 is a constant. Derivative of 1 over x is minus 1 over x squared. So that is the concept I have applied. Let me show it to you again. So this thing is 3x plus 1200 x minus 1. If someone wants to do it in steps, they are most welcome. So this is 1200, this is minus 1, this is x, this is minus 2, which is 3 plus minus 1200 over x squared, which of course is the same thing as what's written on the next page. So when it says find the coordinates of the stationary point, you differentiate it first. And then once it's differentiated, you make it equal to 0. What will you find? You will find the coordinates of x. Simple calculation, no need of a calculator. X comes out to be plus minus 20. 1200 divided by 3 is 400. Square root of 400 is plus minus 20, but already written at the top. What's written at the top? X, Y, Z can only take positive values, so x is plus 20. dz by dx, differentiate it again to find the second derivative. And once you find the second derivative, plug in the value of x is equals to 20. Therefore, the second derivative is positive, numerator is positive, denominator is positive. That means again this is a minimum point. Now you don't have to use the calculator excessively. We knew that 2400 is a positive number. Cube of 20, that's 2 into 2 into 2, which is 8000. That is also positive. Division of 2 positive naturally will give you positive. So why waste the sunlight? Why waste the battery of the calculator? It's gonna be positive, therefore it's a minimum point. So 2 questions are done. Let's move to the third question. A question which involves a graph. It's a cubic graph because x minus 2 whole square, and on the outside there is an x. It's a cubic graph. There is a minimum point at A, there is a maximum point at B. That means it has, of course, something to do with the stationary point. That's why this question is in this video. Now it says the minimum point of the curve has coordinates such and such. X coordinate of the max is B, where A and B are constants. From the graph, you can decide it for yourself that A is positive, B is positive. Maybe, if it comes out to be negative, you have to discard the negative value. State the value of A, find the value of B. Now the question could have simply asked, find the values of A and B. Let's go with that scenario and then we will think, why does it say state A and find B? I am expanding the equation. Be very, very careful, because when I was making this video, I made a small mistake. And even with that small mistake, I was getting answer very close to the original. I don't know, that's some kind of coincidence, magic in math. So you calculate the y, you differentiate it, stationary point y prime equals to 0. It's a beautiful quadratic equation which is factorizable. And make sure you know what middle term factorization is. And you should show every step to the examiner. Make the examiner happy. He'll be more than happy to give you your A star. X comes out to be 2/3, x comes out to be 2. Now it was natural that the bigger value is A, the smaller value is B. Now there are some simple-minded people who say the diagram is not drawn to scale. How can we assume that? It is something different saying that the diagram is drawn to scale or not drawn to scale. But definitely the diagram is not misleading. Number line, x-axis, A is on the right more than close to B. B is closer to origin. A is farther away from the origin. What does that mean? A is bigger, B is smaller. Now, coming back to this, why does it say state the value of B? Because that point is on the x-axis. When a point is on the x-axis, which coordinate is 0? Y coordinate is 0. 2 brackets, 3 brackets, 1000 brackets multiply to give you 0. That means either one of them is 0. Again, I love to talk about simple-minded people. What they do is that they sometimes expand the equation, make it cubic, and then try to solve the cubic equation. Please don't do that. If it's already factorized, simply equal it to 0. And this rule is only about equaling to 0. It's not equaling to any other constant. 3 questions down. Fourth question. A curve has the equation such and such where k is a positive constant. Find in terms of k the values of x for which the curve has a stationary point and determine the nature of each stationary point. I like this question. I like this question because it teaches you that sometimes in math there is a constant which is not going to be evaluated. So bear with that constant, have some patience, treat that constant as a constant and deal with the variable, and things would eventually simplify. Let's look at this question. Y is equals to k square into something. I wrote it with an index, with a power. I differentiated. Let me slow up the speed a bit. Now look at that purple thing. The derivative of the bracket was 1. What is the use of writing 1? We all know that anything multiplying by 1 s will remain the same. The reason of highlighting this simple step is that in chain rule, from my experience, I have seen that when people tend to forget the obvious, something exceptional happens. What happens is that if it was 3x plus 2, people will forget that 3. So even if it's a simple one, even if it's something trivial, don't compromise on the rules of maths. Follow it as it should be followed. Now simplify it out. And this is x plus 2 raised to power of minus 2 plus 1. Write it in the proper format. And when you are doing the differentiation, and it's a concept of stationary point, and they're asking for the nature, so do all the differentiation in one shot. You need the second derivative, don't wait till the very last. Yani some people, what they do is that they first find the first derivative, they find the stationary point, after the stationary point, then they plan, and then they work on the differentiation. I don't like that approach. Personally, I feel when you are doing differentiation, do the differentiation. First derivative, second derivative. Second derivative, you need this red box. You need the index form. Again, follow the procedure. Again, the derivative of the bracket is written, this time in a different color, just so that it looks beautiful. And this is the y double prime. Now, stationary point, make y prime equals to 0. When you make y prime equals to 0, look at the working. Take care of the minus plus sign. Negatives are part of life. They have to be dealt with caution. K comes out to be, we are looking for x. One more thing. Some people, they are very happy and they have found k. We are looking for the x coordinate in terms of k, not the constant in terms of a variable. So we make x the subject. Square root sign plus minus. Now some people, they can ask this question that they are saying that k is a positive constant. So why am I putting a plus minus sign? Because if k is a constant like 4, square root of 4 can come out to be plus 2 or minus 2. That's why I am putting it. If k were to be a negative number, I cannot take square root of a negative number. That is totally different thing. So what is the bottom line of the story? Whenever you take the square root, apply the plus minus sign. In one of the previous questions that involving z, x and y, the reason why we rejected the negative sign, I'm talking about this question, taking you a bit back. In this particular question, I took the positive value only because it said so. It said that x, y, z are positive. This is a different scenario. That is a different scenario. Well, coming back to this, x comes out to be this thing. Now what should I do? There are two values of x, minus 2 plus the square root, minus 2 minus the square root. Write down the y double prime under each one. Simplicity, clarity, that is the name of the game if you want to score a nice grade. Show that you are plugging in this value in this case. Now, 2k square unchanged, minus 2 plus 2 cancels off. Root k written thrice. That is 2k square over k root k. No need to simplify it. All they need is the nature. K is positive, k square is positive. Denominator is also positive. the division, after division, I'll get a positive value. Therefore, it's a minimum. The other one definitely has to be a maximum, but still we'll show the working. Now plug in x is equals to minus 2 minus root k and expand it, simplify it. Minus root k, minus root k, minus root k, multiplying itself 3 times. That's what cube is all about. So denominator is k with a minus root k. Now decide for yourself. Take 5 seconds. Numerator is positive. K is positive. The other k has a negative sign. That means overall it's negative. Therefore, overall double derivative is negative, means it's a maximum. So 1 point is a min, 1 point is a max. Question number 5, the last question of this video. The equation of a curve is such and such where p is a positive constant. I think I've seen so many positives in this video today. Show that the origin is a stationary point on the curve and find the coordinates of the other stationary point in terms of p. Find the nature of each of these stationary points. The first 2 parts, let's handle them. Differentiate x cube plus px square, that is 3x square plus 2px. Differentiate once more, 6x plus 2p. Now whatever I was preaching, whatever I was propagating, actually I did the opposite, my bad. This time, after finding y prime, I'm making it equal to 0. I'm taking common, use common sense to take common. X comes out to be 0, that's the origin. And the other point is minus 2p over 3. What does it say in the first part? Show that origin is a stationary point. Done. And what's the coordinate of the other point? X is minus 2p over 3. So now the thing is, we need to find y prime. And y prime is this thing. Find y double prime. So y double prime is 6x plus 2p. When x is 0, y double prime is positive. So now that is a minimum point, and when x is minus 2p over 3, y double prime is, plug it in, your answer will be in terms of p. Your answer will be in terms of p. That comes out to be minus 2p. P is positive. After multiplication by minus 2, it is negative. Therefore, it's a maximum. What else is needed? What else is needed is that when x is minus 2p over 3, when x is 0, y comes out to be 0. When x comes out to be minus 2p over 3, y comes out to be minus 2p over 3 whole cube plus px square. And then you can simplify and you'll find the other coordinate. So actually they're not asking for the coordinates. If they were to ask for it, I have everything ready. Now let's look at the last part. Another curve has equation such and such. Find the set of values for which this curve has no stationary points. So now the second equation is there. I'll differentiate it. And it says the curve has no stationary point. Now tell me one thing. When a curve has stationary points, how do you find that stationary point? You find it y prime equals to 0. In other words, you solve that equation. It could have been a linear equation, a quadratic equation, a cubic equation, and so on. But when it says there are no stationary points, what does that mean? That means you are not able to solve this equation. And in quadratics, what is the only way that you're unable to solve a quadratic? That means the discriminant is 0. Imaginary roots, b square minus 4ac is less than 0. And that was the logic in this differentiation question. At the end, when you least expect it, quadratic strikes in. So what you get is this. We know from our knowledge of quadratic, drawing a sketch is a must. And less than 0 means region below the x-axis. One single region, one single answer. P lies between 0 and 3. So now these 5 questions on stationary points, I think I love these questions. They are wonderful because using these 5, I was able to explain you all the different type of questions that could come in stationary point. Now this is video 1. Keep tuned, Stay tuned. I think that's the right word. For other videos on stationary points that are related with the most difficult part, similarity, trigonometry, maybe speed, time, distance, something to do with mensuration, 2D, 3D, anything, everything that you can imagine. Take care.